Welcome. In this video, we shall be talking about applications of indices. In our previous videos, we've discussed laws of indices. We gave illustrative examples of how we apply laws of indices. We solved initial and exponential equations. If you're watching this video for the first time, check through this channel and you'll be able to find all these interesting videos on the subtopics of indices. Today we want to talk about the applications of indices. We don't want to let learners see indices as something abstract. We want them to see the beauty of having analytical and problem-solving skills through the knowledge of mathematics. At the end of this video, learners should be able to state at least 2 applications of indices in real-life situation. I remain your math instructor. My name is Abdulahi. This is my beautiful picture at the right side of this video. Let's go straight into business. Application of indices in sports. In World Cup competitions, 32 countries participate. Each group comprises 4 countries. What is the possible numbers of groups we can have in World Cup competition? We can solve this problem using the knowledge of indices. The total number of countries that participate in the competition is 32, which can be expressed as 2 raised to the power 5. The numbers of countries in each group is going to be 4, which can also be expressed as 2 raised to the power 2. The possible number of groups for World Cup competition will be 32 divided by 4, which can be expressed in index form, 2 raised to the power 5 divided by 2 raised to the power 2. Applying the laws of indices, this gives 2 raised to the power 5 minus 2, which is 2 raised to the power 3. And by then we can have 2 times 2 times 2, which gives 8. Do not forget to subscribe to this channel and turn on the bell for notification for the next video. More so, press like, share this video, and also comment on what you've learned in this video. Let's move further. Let's look at the application of indices in set theory. Mathematically, set is a well-defined collection of objects. And among the types of sets, we have power sets. A power set is a set of collection. Or let's say it is a collection that contains all the subsets of a set. For instance, if you have a given set A, 1, 2, 3, we can determine the numbers of members in the power set of A. How do you go about this? The power set of A is denoted by this calligraphic notation of A. We have the empty set because it has been proved that empty set is a subset of every set. And every set is a subset of itself. That is why we started with empty sets and the set A, followed by the singleton 1, singleton 2, singleton 3, followed by a set containing element 1, 2, another one containing element 1, 3, and 2, 3. By counting, we have 8 members. 1, 2, 3, 4, 5, 6, 7, 8. By law of indices, we can demystify this problem using the formula. The number of members in the power set of A will be 2 raised to power the number of elements in set A, which is 2 raised to power. The element in this set A is 1, 2, 3. We have 3 elements. It's not because I'm having the number 1, 2, 3. I'm counting in terms of the number of elements. 1, 2, 3. So this is 2 raised to power 3, which is 2 times 2 times 2, which is 8. And this is the same answer when we highlighted the members of the set and count. Which of the method do you think works faster? This works faster. You don't need to rack your brain to find out the number of elements in the power set of A before you determine the number of elements in the power set of A. You just need the formula, which is straightforward with the knowledge of indices. Let's move into the application of indices and probability. Mathematically, probability of an event, say E, is the ratio of the number of favorable outcomes to the number of possible outcomes. We express it in this way in the mathematical notation. So the possible outcomes is also known as the sample space. And the sample space is the set of all possible outcomes in the occurrence of an event. For instance, in a random experiment of tossing a coin, you have 2 possible outcomes. Head is either you have head or you have tail. What are the possible outcomes in tossing a coin twice? Is either you have head, head, tail, tail, head, and tail, tail. So number of possible outcomes is 4. By the knowledge of indices, we can get this done without stating out the members of the set, without stating out the members of the sample space. And the formula is the number of possible outcomes equals the number of possible outcomes in objects. In this case, what we mean by object is either coin, die, card, anything you can think of. Raised to power the number of times object is thrown or tossed, and this gives 2 raised to power 2, which is 4, which is the same thing as the results you have here by highlighting, by stating out, by itemizing the members of the sample space. But using the formula, it works faster. Also, in a case whereby you need a number of possible outcomes in throwing a dice twice, that's in a die, the number of possible outcomes, we have 6 faces, that is 6. The number of times 2, 6 raised to power 2, which is 6 times 6, that is 6. The same thing when you have a die thrown thrice, you have 6 raised to power 3, which is 2, 1, 6. Take note, when you are dealing with probability problem, the number of outcomes when the coin is tossed twice is the same thing as the number of possible outcomes when the 2 coin is tossed once. The number of outcomes when the dice is thrown twice is the same thing as the number of possible outcomes when the 2 dice is thrown once. The same thing when a dice is thrown thrice is the same thing as when 3 die is thrown once. I hope you have learned something from this video. Tell us what other activities involve the application of indices in the comment section of the video. Thanks for watching, and do not forget to subscribe and turn on bell for notifications. Bye for now.